Hi guys, welcome back. In previous video, we discussed about a procedure of finding asymptotes of a given curve. In previous video, I missed something to define. Uh, if a curve, if a curve has to possess oblique asymptote, then it must and should have what we call x power of n alone and y power of n alone in their equations. Then and only, uh, then only the given function will have an oblique asymptote. I forgot to mention this thing in a previous video. I'm mentioning it over here. Yeah. Now let's discuss an problem regarding asymptotes. Yeah. Just look at this problem. By looking this problem, we can say that this curve is not going to have any oblique asymptotes because we don't have any here x power 4 or y power 4. We just directly have x square into y square and something extra. And here we can note that degree is equal to 4, and we don't have any x power 4 or y power 4, so this curve is not going to have any oblique asymptote. Yeah. Now we are left with only two type of asymptotes. Those are, first one is asymptote parallel to x-axis. That in the sense y is equal to some k. Yeah. For finding those type of asymptotes, I just told you guys, just consider uh, uh, highest degree of x and its coefficients. Highest degree of x in this function is x square. Yeah. And x square into y square minus y. This is the highest function of x, and these are the coefficients of that function. We are going to equate it to these things to 0. That implies y square minus y equal to 0. Y into y minus 1 equal to 0. That implies y is equal to 0 comma y is equal to 1 are the asymptotes parallel to x-axis. Likewise, and now we are going to find the asymptotes parallel to y-axis. Parallel to y-axis. Ring with x equal to some k. Yeah. Here in this function, here in this function, highest power of y is y square and y square. We are going to consider y square into its coefficient x square minus x. We are going to equate it to 0, and then we are going to get some values of x square minus x equal to 0. That implies x equal to 1 comma x equal to 0. These are the asymptotes parallel to y-axis. Yeah, we are able to find the total asymptotes of this curve. Now I can say that asymptotes of the given function are x equal to 0, comma x equal to 1, and y is equal to 0, comma y is equal to 1 are the asymptotes of of f of x, comma y. Yeah, just now look at this example. By seeing this example itself, we can say that it's going to have only oblique, because if an what we call, if a function to have uh, asymptotes parallel to x and y axis, it must and should be a function of x square into y coefficient, y square into some x coefficient. But here we have x cube alone, and here we have only y cube alone. So these type of functions won't have asymptotes parallel to the axis. This type of functions will have only oblique asymptotes according to our procedure. Now we will find, first just take x equal to 1 and keep y is equal to m in third degree term. Yeah. 1 plus 3 into 1 into m minus 4m square m cube equal to 0. That implies minus 4m cube plus 3m plus 1 equal to 0. 5 3 of m. Similarly, we will find phi 2 of m. Phi 2 of m. That is x equal to 1 and y is equal to m in second degree. Yeah. Here we don't have any second degree functions. Just see. We don't have any second degree functions. So we are going to keep it to 0. Now from here we will find the values of m. By solving this equation, we will get the values of m. Minus 4 plus 3 plus 1 equal to 0. If the coefficients, sum of coefficients are equal to 0, then we can take 1 as one of its root. It's a simple shortcut which we might have learned it in our high school level. M is equal to 1 is one of its root. Then if we do synthetic division and if we find its root, it's going to be like half or minus half is one of its root, and another m will be something. I don't know. I don't remember it. These are the three roots. But here value of m doesn't make any sense because already phi 2 of m is 0. We have c is equal to phi 2 of m by phi dash 3 of m. Whatever it might be, the whole function c will be 0. Just 0 by something is equal to 0 always. We will get y is equal to m1x, y is equal to m2x plus y is equal to m3x. Here m1, m2, m3 are the roots of this function. That's it. We found the three asymptotes of the function. These are the typical questions regarding asymptotes. We can't expect much more than this. Thank you guys. Thank you for supporting. Please share this video with your all BTech friends so that it gives me some boosting to make much more videos. Thank you. And let's meet you in next video. Bye.